solution, we have to integrate the function 6x plus 7 divided by square root of x minus 5 into x minus 4. Let's begin with the solution, and we have to evaluate integral 6x plus 7 divided by square root of x minus 5 into x minus 4 into dx, and this can be written as integral of 6x plus 7 divided by square root of x square minus 9x plus 20 into dx. Now, if we have the integral of the type px plus q divided by square root of ax square plus px plus c into dx, then in this case we try to write the numerator, that is px plus q, as a into the derivative of ax square plus px plus c plus the constant b. Therefore, let us write 6x plus 7 equal to a into the derivative of x square minus 9x plus 20 plus b, and this is equal to a into 2x minus 9 plus b, which is equal to 2ax plus b minus 9a. So on comparing, we see that 2a is equal to 6, which implies that a is equal to 3, and b minus 9a is equal to 7, that is b minus 9 into 3 is 27, is equal to 7, which implies that b is equal to 27 plus 7, which is equal to 34. Therefore, 6x plus 7 can be written as a into 2x minus 9, and a is 3, so we have 3 into 2x minus 9 plus b, and b is 34. Therefore, integral of 6x plus 7 divided by square root of x square minus 9x plus 20 into dx can be written as, replacing 6x plus 7 by 3 into 2x minus 9 plus 34, we have 3 integral of 2x minus 9 divided by square root of x square minus 9x plus 20 into dx plus 34 integral of 1 divided by square root of x square minus 9x plus 20 into dx. Now let us suppose the first integral as I1 and second as I2. Beginning with I1, let us suppose that t is equal to x square minus 9x plus 20. On differentiating both sides with respect to x, we get dt is equal to 2x minus 9 into dx. Therefore, integral I1 can be written as dt divided by square root of t, that is integral t raised to the power minus half into dt, which can be written as t raised to the power minus half plus 1 divided by minus half plus 1 plus the constant c1. This is equal to 2 into square root t plus the constant c1. So this is equal to 2 into square root of t we have supposed as x square minus 9x plus 20 plus the constant c1. So this is the value of the integral I1. Now we have integral I2, which is integral of 1 divided by square root of x square minus 9x plus 20 into dx. Now using ax square plus bx plus c, which is equal to the right hand side as shown, we can write x square minus 9x plus 20 equal to, a here is 1, so we have x minus 9 upon 2 whole square plus 20 minus b square, and d square is 81 divided by 4 bracket close. So this is equal to x minus 9 upon 2 whole square. From here we get minus 1 upon 4. So taking minus sign common, we can write 1 upon 4 as 1 upon 2 whole square. Therefore, integral I2 can be written as integral of 1 divided by square root of x minus 9 upon 2 whole square minus 1 upon 2 whole square into dx. Now let us suppose that x minus 9 upon 2 is equal to t. So this implies that dx is equal to dt. Therefore, I2 now becomes dt divided by square root of t square minus half square. Now, we know that integral dx divided by square root of x square minus a square is equal to log mod of x plus square root of x square minus a square plus the constant. Therefore, integral I2 can be written as log mod of t plus square root of t square minus half whole square plus the constant c2. Now t we have supposed as x minus 9 upon 2. So this can further be written as log mod of x minus 9 upon 2 plus square root of x minus 9 upon 2 whole square minus half whole square plus the constant c2. And this is nothing but, we started here from x square minus 9x plus 20 and we arrived at x minus 9 upon 2 whole square minus half whole square. So this can be replaced by log mod of x minus 9 upon 2 plus square root of x square minus 9x plus 20 plus the constant c2. Now the given integral is equal to 3i1 plus 34i2. Therefore we have, now substituting the value of I1, which is 2 into square root of x square minus 9x plus 20 plus c1. So we have 3 into 2 times the square root of x square minus 9x plus 20 plus the constant c1 plus 34 into I2, which is log mod of x minus 9 upon 2 plus square root of x square minus 9x plus 20 plus the constant c2, and this is equal to 6 square root of x square minus 9x plus 20 plus 34 log mod of x minus 9 upon 2 plus square root of x square minus 9x plus 20 plus the constant c, where c is equal to 3c1 plus 34 c2. So this is equal to the given integral 6x plus 7 divided by square root of x minus 5 into x minus 4 into dx. This completes the solution.